If you've always wanted to learn programming but don't know where to start, this video is for you. We'll break down what a programming language actually is, how it works behind the scenes, where different languages are used in the real world, which ones companies actually hire for, and the exact learning approach beginners can use to avoid getting stuck or overwhelmed. By the end, you'll have a clear roadmap, a practical learning strategy, and the confidence to start coding the right way. When people hear the word programming, it often sounds complicated, as if it's a world full of symbols, rules, and confusing text. But the idea behind a programming language is actually very simple. A programming language is just a way for humans to give instructions to a computer in a form that we can write and understand. To see why programming languages even exist, it helps to understand the communication gap between humans and computers. Humans think in concepts: show this, calculate that, save this file, or play a sound. These are fairly high-level ideas. Computers, on the other hand, don't understand concepts at all. They only understand electrical signals, a long sequence of zeros and ones that represent tiny on-off switches inside the CPU. If we tried to communicate directly in that format, it would be impossible for us to write or understand anything. Even a simple action like adding two numbers would require thousands of binary instructions. So there needs to be something in the middle, a tool that takes the ideas we write in a human-friendly form and converts them into the low-level signals the machine understands. That middle layer is the programming language. A programming language acts like a translator. You write your instructions using a structured set of words and symbols, and then another piece of software, called a compiler or an interpreter, converts those instructions into machine code. The computer then executes that machine code and performs the action you requested. You never have to think about the zeros and ones yourself. The language handles that translation for you. There are hundreds of programming languages today, but only around 50 are widely used in real commercial development. So you might ask why so many different languages exist in the first place. A helpful way to understand this is to think about the different ways we give directions. There are many ways to guide someone to the same destination. You could draw a map, give step-by-step instructions, or describe the landmarks they'll pass along the way. All of these methods achieve the same goal, but each one uses a different style. Programming languages work the same way. Python gives instructions in a simple and readable format. C++ gives very precise and detailed control. And JavaScript is designed specifically for the web. These differences in style exist because different tasks require different approaches. Some languages are meant to be easy to learn, some are built for speed and efficiency, and others are optimized for building websites, controlling hardware, or running large applications. Just like a toolbox holds many tools for different jobs, the programming world has many languages, each one designed to help you build something in the way that works best for that particular task. Once you understand this, programming becomes much less mysterious because you now see it for what it really is: a communication tool between you and the computer. Now that we understand what a programming language is, the next step is to look at how these languages actually work behind the scenes. Every language has its own personality and way of doing things, but they all share a few common features. Once you understand these parts, the whole programming process becomes much easier to make sense of. At the center of every language is something called syntax. Syntax is simply the set of rules that describe how you're supposed to write the language. Just like English has grammar, where words go, how to form sentences, and what punctuation means, programming languages also follow their own grammar. Python uses indentation to show structure, C++ uses curly braces and semicolons, and JavaScript has its own keywords and patterns. If you break these rules, the computer won't understand what you're trying to say and will show an error. So syntax is the foundation that allows you to express instructions correctly. After you write code, the computer still can't understand it directly. It must be translated into the zeros and ones the CPU understands, and different languages do this in different ways. Some languages use a compiler, which translates your entire program ahead of time. Once the translation is done, the program runs very fast. Others use an interpreter, which reads and executes your code line by line. This makes development flexible and beginner-friendly, even if it's not always as fast. And some languages use a runtime, like Java's JVM or the .NET environment. These runtimes add an extra layer that helps manage memory and keep your program running consistently across different machines. Most programmers spend their time working inside something called an IDE, or Integrated Development Environment. An IDE is simply a software application where you write, test, and run your code. It brings together everything you need: a text editor, tools for finding errors, buttons for running your program, and sometimes even suggestions or auto-completion as you type. Another important feature of an IDE is debugging. Debugging is the process of finding and fixing mistakes in your code, and IDEs make this much easier by letting you run your program step by step, inspect the values of variables, and see exactly where something went wrong. Instead of guessing why your program isn't working, the debugger shows you the problem directly. Examples of IDEs include Visual Studio Code, PyCharm, IntelliJ, and Visual Studio. IDEs don't change how programming languages work at a technical level, but they make the experience of writing and correcting code much smoother and more beginner-friendly. Beyond the IDE and the language itself, modern programming relies heavily on something called libraries and frameworks. They're both tools that help you build things faster, but they play slightly different roles. A library is a collection of pre-written functions that you call when you need them. You stay in control, and you decide when and how to use the library. For example, Python's Pandas library helps you work with data, so instead of writing dozens of lines of code to filter or clean a dataset, you can do it with 1 or 2 commands. A framework is different from a library because it gives you a pre-built structure for your project. Instead of starting from a blank page, the framework gives you folders, patterns, and rules to follow so your project stays organized from the beginning. You can think of it like walking into a house where the foundation, walls, and wiring are already in place. All you have to do is fill in the rooms with your own ideas. The framework decides the overall layout, and you focus on building the actual features. For example, the Django framework for Python gives you a ready-made structure for handling databases, routing, authentication, and security. Instead of building these features from scratch, Django hands you a blueprint and says, "Here's the foundation, just add your logic." Once you understand how these pieces fit together, programming becomes a clear process. You write the ideas, the tools translate them, and the computer does the rest. Now that we've seen how programming languages work behind the scenes, the next step is to look at where these languages appear in the real world. Each language has a natural place where it fits best, whether that's the web, mobile apps, artificial intelligence, games, or even embedded devices. Seeing how languages map onto different industries makes the entire programming landscape much easier to understand. Web development. When people talk about building websites or web applications, they're usually describing 2 major parts, the front end and the back end. The front end is everything the user sees, the buttons, layouts, colors, and animations, and it's built using HTML, CSS, and JavaScript. Modern frameworks like React and Angular make it easier to create dynamic, interactive pages that feel smooth and fast. The back end is the part the user never sees. It handles things like user accounts, data storage, and server logic. Historically, PHP dominated much of the web and still powers a huge portion of today's websites, especially through frameworks like Laravel. JavaScript, through Node.js, is also extremely common because it lets developers use one language for both the front and back end. Python, Java, Ruby, Go, and C# also appear frequently, each with their own frameworks that help structure applications. Different companies choose different back-end stacks, but the overall goal is the same: keep the website fast, reliable, and secure. Mobile development. In mobile development, the tools you use depend heavily on the platform you're building for. Android apps are written in Kotlin or Java and rely on Google's official frameworks like the Android SDK and Jetpack Compose. iOS apps use Swift or Objective-C and are built with UIKit or Swift UI, which are Apple's frameworks for designing screens and interactions. Not every team wants to maintain 2 separate code bases, so cross-platform tools like Flutter and React Native have become popular. They allow you to write one set of code and deploy it to both Android and iOS, which can save massive development time, especially for startups and small teams. Data science and artificial intelligence. In data science and AI, Python is the clear leader. Frameworks like TensorFlow, PyTorch, and Pandas give developers everything they need for machine learning, data analysis, automation, and model training. That's why almost every AI tutorial, research project, and real-world machine learning system starts with Python. Game development. Game development requires very high performance, which is why languages like C++ and C# are common. C++ powers engines like Unreal, while C# is used heavily in Unity. These tools handle graphics, physics, and gameplay systems, letting developers focus on designing the game itself. Embedded systems and hardware. Embedded systems run on electronic devices like sensors, robots, and IoT hardware, where efficiency matters. Languages such as C, C++, and Rust are used because they give developers tight control over memory and performance. Platforms like Arduino or ESP32 make it easier to work directly with electronics. When you look at the global job market, a few languages consistently appear at the top. JavaScript, Python, and Java make up a huge portion of real-world development, simply because they're used across so many industries. JavaScript is everywhere on the web, which means every company with an online presence needs it. Python dominates AI, automation, and data analysis, which are some of the fastest growing fields today. And Java remains one of the most important languages for enterprise systems, banking software, and Android apps. After these three, demand becomes more specialized. Kotlin and Swift dominate modern mobile development. C++ is common in finance, high-performance applications, and game development. Go is heavily used in cloud services and companies that need fast, scalable backends. C# appears frequently in Windows development and game studios using Unity. Rust shows up in security-focused and systems-level work. So while many languages are useful, the broadest hiring opportunities tend to cluster around JavaScript, Python, and Java, with others providing high-value roles in more specialized fields. Some languages are designed to be friendly for beginners, while others require a more detailed understanding of how computers work. Python is usually the easiest starting point because its syntax feels natural and allows you to focus on the logic instead of the rules. JavaScript is also beginner-friendly and gives immediate results on the web, which makes learning feel more rewarding. Java adds more structure and rules, which can feel strict at first, but helps build good programming habits. C++ and Rust sit on the more challenging end of the spectrum because they require more control over memory and performance. They're powerful languages, but they demand more precision from the programmer. So if you're learning your very first language and want the easiest path forward, Python or JavaScript typically provides the smoothest introduction. Choosing your first language becomes much easier once you understand what languages are used for, which ones are in demand, and which ones are easier to learn, all of which we've already explored. So instead of repeating those details, let's simplify everything into a clear decision guide. If you want the smoothest possible introduction to programming, Python is almost always the best place to begin. It has gentle syntax, it's widely used across many fields, and it lets you focus on learning core programming concepts without getting overwhelmed. If you're aiming for a career in web development, the answer is straightforward. Start with JavaScript. Every website relies on it, and most modern front-end development is built around frameworks like React. Depending on the kind of web projects you want to build, you can later pair JavaScript with Node.js, Python, or PHP on the backend. The specifics of those stacks will make more sense once you start building real projects. If your goal is mobile development, the choice depends on the platform. Kotlin is the main language for Android, Swift is the standard for iOS, and Flutter is ideal if you want one codebase that works on both. And if you're interested in artificial intelligence or machine learning, the path is even more direct. Nearly every major AI tool and library is built around Python, making it the natural language for anyone entering the field. If AI is your long-term destination, starting with Python is the clearest route. Finally, if you want the broadest job opportunities, learning JavaScript and Python together gives you an enormous amount of flexibility. One powers the web, the other powers data science, automation, and AI. Together, they cover a massive portion of modern tech, letting you move between different roles as your interests evolve. Learning how to code can feel overwhelming at first. There are so many languages, endless tutorials, and a lot of conflicting advice online that it's easy to feel lost before you even begin. But the truth is, programming becomes much simpler once you follow a clear path and focus on the things that actually matter. You don't need to learn everything, you just need consistency, curiosity, and the right resources. A good place to start is by picking one beginner-friendly language and sticking with it long enough to build a solid foundation. Most people begin with Python or JavaScript because they're easy to read and widely used. The mistake many beginners make is jumping between too many languages too early. But all programming languages share the same fundamentals. If you stay with one language long enough for the basic ideas to click, everything else becomes easier later. From there, the way you choose to learn depends entirely on what suits you. Some people prefer the self-taught route using roadmaps, tutorials, and documentation at their own pace. Others learn better inside a structured environment like a boot camp, where they get mentors, assignments, and project reviews. And some start with a computer science degree, which provides strong academic foundations, but isn't required for most programming jobs today. There's no single best path. What matters is picking the approach you can stay consistent with. No matter which path you choose, one tool that helps almost everyone is a roadmap. A roadmap is simply a guide that tells you what to learn first and what to learn next. One of the most useful sites for this is roadmap.sh, which offers clear paths for web development, backend development, DevOps, data engineering, machine learning, and more. These roadmaps keep your learning organized, but they're not checklists you must complete line by line. Real programmers don't master every item on a list. They learn what they need for the projects they're building and pick up the rest later. So use a roadmap for direction, but don't let it overwhelm you. As you start learning, one of the biggest shifts you'll need to make is moving from memorizing syntax to actually building things. Tutorials introduce concepts, but projects teach you how to think like a programmer. Start with tiny, manageable projects, maybe a calculator, a simple website, or a small tool for a real-life problem. Finishing something, even something very small, teaches you far more than watching hours of tutorials passively. Along the way, you'll run into errors, lots of them. This is normal. In fact, errors are one of the best teachers you'll have. When something breaks, the error message is usually telling you exactly what went wrong. The moment you stop feeling afraid of error messages and start reading them carefully, programming becomes much less intimidating. Confidence grows quickly once you realize you can debug your own code. You'll also learn faster if you make use of the programming community. A quick Google search or a Stack Overflow thread can solve most problems you run into. Discord groups and open source projects on GitHub show you how other people structure and write code. And when you need something explained more clearly, reputable tutorials can fill in the gaps. Seeing how other developers think and how they solve problems is one of the fastest ways to grow. As your skills develop, it's important to start recording your progress. A GitHub profile with even a few small projects can say far more about your abilities than a certificate or a resume. Employers want to see that you can build things independently. Your portfolio becomes proof of your skills, your effort, and your growth as a developer. If you ever feel stuck deciding what to build, roadmap.sh has a project section that offers practical project ideas separated by skill level and language. These projects come with guidelines on what to build and how to structure it, but they don't give you full solutions. You have to figure things out for yourself. That's what makes them so valuable. They push you out of tutorial mode and into real problem solving, which is where the real learning happens. And finally, AI can be a powerful assistant in your learning journey if you use it wisely. It can explain error messages in simple terms, break down concepts you don't understand, give examples of how certain functions work, or help you structure a project into smaller steps. It can even review your code and suggest improvements, but you should avoid copying and pasting AI-generated code without understanding it. If you let AI do the thinking for you, your own skills won't grow. Instead, use AI as a teacher. Ask it to explain the reasoning behind a solution. Make sure you understand why the code works, not just what it does. Used this way, AI accelerates your learning rather than replacing it. When you combine these ideas, starting with one language, following a simple roadmap, building small projects, learning from errors, using community resources, documenting your progress, and treating AI as a guide, you create a learning process that's clear, manageable, and effective. Programming becomes much less mysterious, and the entire journey feels far more achievable. In the end, programming isn't about memorizing rules. It's about knowing how to learn, practice, and build. With the right starting language and a clear path, you can grow faster than you think. So take the first step and keep going. And if this video helped you, feel free to like and subscribe. It really supports the channel and helps more learners find this content. Thank you, and I'll see you in the next video.